Hi everyone, and welcome to another episode of Mrs. Ross Does Math. This is for Algebra 1B. Our section that we're going to be working on today and learning about is Chapter 8.7. In this section, we're going to be focusing on two items, factoring the differences of squares and factoring perfect square trinomials. Today, our focus is going to be on factoring differences of squares. Now, the key word there is differences, and that's something that we're going to need to take into account in this lesson. Okay, so I'm going to underline the word differences. Now, our essential question for this section is, how do you factor special products? So remember, products is the math word for multiplication, so we're going to be factoring different multiplication-based problems. Now, we do have a key vocab word for this unit, and that is going to be square roots. Now, here, we're going to be factoring the differences of squares. Squares are also square roots. So our definition of a square root is a value that can be multiplied by itself to give the original number. So an example of that is the number 16. Now, the square root of 16 is both 4 and negative 4. The reason why is because 4 times 4 gives us 16, and negative 4 times negative 4 gives us 16. So therefore, we have the square roots of 4 and negative 4 for 16. Now, if it simply asks for the square root and we have the root symbol, meaning this here, so the square root of 16, when we see this symbol, that means only positive numbers. So in this case, if we see square root 16, we could only have the positive 4. We can't have a negative underneath the square root symbol. Now, the square root symbol today is going to become one of your best friends in this unit. So I really want you to know what that symbol is. Now, moving forward, I have a little insert. Some of you already have this, and it is this here. It is factoring difference of squares. So, we will be using factoring difference of squares when the degree is 2. Meaning it is a quadratic. In other words, we have x squared minus 16. We need this squared here. Now, the next piece is that our number of terms is also 2. This is a binomial type problem. And lastly, we must be able to take the root of both our A term and our C term. So, in here, once again, we're talking about factoring the difference of squares. So here, when we see this word difference, we're talking about this sign right here, that negative. Ultimately, what we're going to be doing is we need to make sure that that negative sign is there, because we are going to be finding the square root of both the A term and the C term. So, in here, when we're looking at some steps for factoring success, the first thing that we're going to do is we're going to take the square root of the first term. Okay, I'm going to find the square root of the first term, meaning in this case, the A. The A is my first term. Then I'm going to find, for step 2, the square root of the second term, my C. My last step is I'm going to make one parentheses a positive and the other parentheses a negative. So that means in here I'm going to have a plus sign and I'm going to have a negative. Now the reason why is because when I multiply my terms together, the middle terms will end up canceling out. That's why one of these has to be positive and the other has to be negative. Now looking at this, we have an example. And our example is going to be 81x squared minus 36. So, using this example, we are going to find the square root of 81. Okay? So the square root of 81. Now the square root of 81, the same number that multiplies by itself to give us 81 is 9. So I'm going to have 9 and 9. But this is not just 81. This is 81x squared. Because I have the x squared here, this is going to be 9x and 9x. Now, my square root of 36. My square root of 36 happens to be 6. So I get 6 and 6. What that means now is that in my parentheses, once again, one of them is positive, the other is negative. I'm going to have 9x at the beginning of each one, and I'm going to have a 6 at the end of each one. This would end up being my final answer. 9x plus 6 and 9x minus 6. Those are in our parentheses. Now, ultimately, we would need to check this. So setting up our box method to check, I have 9x and I have 6. I have 9x and negative 6. So 9 times 9 is 81, x times x, x squared. So I get 81 x squared. Now 9 times 6, that's 54. I'm going to add an x to it, so we get 54x. Now we've got negative 6 times 9. That'd be negative 54, and I'm going to add an x, so negative 54x. And negative 6 times 6, that's negative 36. We're going to add our middle terms together. They cancel out, leaving us with 81x squared minus 36. Now another way for us to check this is really just to do a simple checklist. So, to check, do we have two terms? Yeah, I have term 1, term 2. Next, is there a difference? Meaning, is there a minus sign separating our two terms? There is. Lastly, were we able to find an even square root? Yes. The square root of 81 is 9. The square root of 36 is 6. So we have 9x plus 6, 9x minus 6. And that would be our final answer. Now, what we're going to do next is a couple more example problems to help make sure that you have solid footing in this assignment. Now, as we get these going, if you have any questions, you need a pause or anything like that, please pause this video and do what you need to do in order to best serve you. If you have any questions or need anything, please leave me a comment, send me a message, and I will do everything I can to help. Now, moving forward, I have 3 example problems for you. The first example problem is this one here. 9m squared minus 64. Now once again, this is 9m squared minus 64. So we are going to begin by finding the square root of our first term. The square root of 9 is 3. The square root of m squared is m. So each one of my 3's will include an m. My square root of 64 is 8, so I'm going to have 2 8s. Putting this together, we're going to have our parentheses. We're going to have 3m plus 8, and we're going to have 3m minus 8. This is our final answer. So we're going to circle it. Next, we have an additional one. Here, I have b to the 4th minus 16. Now, this is a little bit of a tricky problem, and I'll explain why as we go through this. To begin with, we are going to get b to the 4th. We need to find the square root. The square root of 4 is what we're going to be looking at. The square root of 4 is 2, so I'm going to have 2 sets of b squared. And the square root of 16 is 4, so I'm going to have 2 4's as well. Now putting this together, I'm going to have b squared minus 4, and I'm going to have b squared plus 4. Now, taking a look at this, some people might think that we could break down our b squared and the minus 4, because this is an additional problem. And we can. The square root of b squared, that's b. So here, b times b is going to give me b squared. B, in this case, sorry, not b, 4 can also be broken down. The square root of 4 is 2, so we're going to have 2 times 2. So, putting this together, we're going to have b plus 2, we're going to have b minus 2, and we're going to have the b squared plus 4. Now, the reason why I'm not breaking down my b squared plus 4 is because of this plus 4. That 4, because it is a positive and not a negative, cannot be broken down. Because the only way for our middle term to be erased or to go away is by having a negative in front of that 4. We can't do that with this particular problem, so therefore the b squared plus 4 remains. So our final answer is b plus 2, b minus 2, and b squared plus 4. Now the last problem that we have is this one here. X squared minus y squared, and that's it. Now we have no numbers here, so we're going to have to treat these squareds up top like our numbers. Now in this case, x times x would give me x squared. So I'm going to write that down. Now y times y would give us our y squared. So putting this together, I'm going to have x minus y, and I'm going to have an x plus y. Now by doing that, because one of these terms is negative and one of these terms is positive, my middle term will go away, leaving me with simply the x squared minus y squared. Now once again, if you guys have any questions, please leave me a comment. Please rewind this video. Do whatever you need to in order to best understand this material. Now the next piece that we're going to go over is your assignment for this. Now your assignment for this is a little bit interesting. For this particular section, you are going to be doing some specific numbers out of the textbook. And that happens to be page 545. And for this one, the factoring special products, that's what this one is here. This is your factoring special products. what you're going to be doing is numbers 2 through 8 and numbers 15 to 23 odd. Now 2 through 8 is all. So, taking a look at this, our assignment is right here. Okay. So, for this is, again, page 545, numbers 2 through 8 all, and 15 to 23 odd. Okay. Here, once again, our focus is on the difference of two squares. We're taking a look at this. For this assignment, I've given you a copy of this page in the packet that was sent home. If you have your textbook, I would also recommend utilizing that. Please do this assignment on a separate sheet of paper. Now, for this, there is one particular problem that I want to review first, and that happens to be number 7 in this section. Now, for number 7, we cannot find the square root of -3. It doesn't happen. There is no square root there. So what we're going to do for this particular problem is we are going to need to factor out that -3 from our problem in the -3m squared plus 48n squared in order to be able to figure out what our answer actually is. So for this, oh, that page doesn't work. So for this, for number 7, again, we have -3m squared plus 48n squared. We only want whole numbers. If I find the square root of -3, that is not pretty. And the square root of 48, that's not pretty either. So what I'm going to do is I'm going to divide instead. I'm going to divide each one of these numbers by -3. So I'm going to divide it by -3 here and by -3 there. Now by dividing it there, my -3 goes on the outside, and what I'm left with inside, my -3's cancel here, leaving me with m squared. 48 divided by -3, that's going to give me -16. So a workable problem that I have is -3 parentheses m squared minus 16n squared. Now we are going to find the square root of m squared, and that's m. The square root of 16 and 16n squared would be 4n. So putting this together, we would have the problem of -3 parentheses m minus 4n and m plus 4n. This would end up being our final answer. So if at any point you cannot find a nice, pretty whole number square root for a problem or for a variable, try pulling a number out and seeing if that will work. 99% of the time, that's what you're going to need to do. Whether it's dividing by a negative, dividing by a positive number, maybe it's even just a -1 that you need to divide by. But remember, we always need to have a minus separating out our two terms. If that negative sign is, or that minus sign is not there, it is no longer a difference of squares. And that's what you're going to need to pay attention to. Once again, if you have any questions at all, please leave me a comment. Please send me a message. Please rewatch this video. If you need additional examples, please, once again, leave me a comment, send me a message, and I will do everything I can to help you guys out. Thank you so much for watching. This has been Mrs. Ross Does Math.